Hey, I want to give out a big thanks to Michael and his whole team. This is just amazing. What a great setup. You guys really knocked it out of the park. So, I'm going to talk a little bit about iMachining, but maybe not in the traditional way that we've seen it talked about before. So I kind of want to take you down a little bit of a different road. The iMachining revolution and what that means and how we can capitalize on that with both our resellers and with our customers as well. We may not be telling this story as well as we should. Emil likes this statement. I love this statement, that if you're not using iMachining, you're losing money every day, okay? But a lot of people haven't figured that out just quite yet. And Emil asked me a question: why aren't more people buying it? Because it's so amazing. Well, maybe it's because we're not taking everybody to that next level. And that's what I want to kind of take us through here today and help you understand where we can go with iMachining. It is phenomenal. It's been out since we released it in early 2010, and it has changed a lot of the ways that people use our software and think about machining, milling metal in bulk material removal. It was designed for first cut success. There's not too many people that I hear of that pull up an iMachining toolpath, set the slider, and don't have success. It works really well, okay? It is a little bit conservative, but it's a great improvement over a traditional toolpath. But over the years, other companies have come out with toolpath ideas that they claim are the same, and they're not. iMachining is uniquely different in this world. And so I want to challenge everybody that is technical, that's using this, that's teaching people how to use this. When you think about feeds and speeds, how are you thinking about it, okay? Do you think chip thickness, or do you think chip load? Chip load is at the front of the tool. Chip thickness is actually at the contact point of the tool. How do you think about the spindle speed? Are you thinking about the velocity of the cutting edge, or are you thinking about the RPM of the spindle? These are things that we need to take people down a little bit of a different line. Are we thinking about step over like everybody else in the industry does? Or are we thinking about the heat generation cycle of that tool going through the material, which is that range between the minimum and maximum cutting angle, okay? That's a different way of looking at how that tool is interacting with the machine. Now, a lot of us are very, very passionate about iMachining. And we need to share that passion. We need to get other people excited about it. We have a lot of fun at the trade shows, and I'll talk a little bit about that in a while. But how do we take people to the next level? How do we take ourselves to the next level? That comes by learning and understanding a little bit about the science of what's going on in here, and understanding that the installed defaults are conservative. They're conservative for a reason. It was a brilliant decision to make safety and first cut success what we are promoting to the customers worldwide. We don't want somebody jumping in, looking at these feeds and speeds in our videos and going, wow, that's super fast, and then breaking something. So we set them up so they wouldn't do that. But we need to master the Modify Cutting Conditions page, okay? Now, as you look up here and you see this, there's a button right there in the middle, a tab, that takes us over to the Modify Cutting Conditions page. I talk to a lot of people, a lot of customers that aren't aware of this. Now, one thing I will say, and please be aware of this, see that wizard button over there? Don't ever turn that off. We never ever want to run iMachining without the wizard. The wizard is what makes it what it is, and it gives us some really, really powerful benefits out there. But we want to use it at its most productive level, and I'm going to show you a couple of videos here that talk a little bit about that. Don't be scared. We can change things. You notice in here there's 3 items checkboxed. I've taken over a little bit of the settings of the parameters instead of just leaving it to the wizard. Now, one thing I will say is an easy way to start playing is to get into this cutting control page, the modify cutting control page, and start experimenting. Do one thing at a time. Don't change a whole bunch of things and then see what it does. But you can get in here and you can kind of play around with this, and you can start to see how different parameters affect the cut and affect the chip load and everything else. And so let's talk just a little bit about that science. I'm not going to go into a technical dissertation or anything here, but I do want to talk a little bit about what we're doing because I think this is kind of cool stuff. We're not really cutting steel or metals. We're actually doing a process known as plastic deformation. It is what is called chip forming, okay? And as you can see, as this video is showing here, this is what chip forming looks like at a microscopic level. Now, there's an energy that is involved with this, and that energy is something that we really need to pay attention to if we're going to take advantage of what iMachining can do for us. You'll notice underneath the tool there, it was kind of bending down and coming back up. That's elastic deformation. What was happening over there on the right side where it was wrinkling, that is what's plastic deformation, and that requires a bunch of energy to do that. Another thing that we need to think about is chip ejection. We're moving a lot of material very, very quickly, okay? So in the industry, a lot of the competitors are targeting these high flute count tools, like 9, 11, 8 count tools. Well, we got to be careful about that because chip ejection is critical, and we don't want to, when the count of the flute gets up higher, the size of the ejection cavity comes way down, and so we can get binding and problems. But we can do things differently with iMachining than what they're doing by increasing the chip thickness, increasing the cutting angle, and taking advantage of how well we utilize and manage that energy that is put out. Now, some of you have probably seen this several times, but this is a great illustration. It's not the right physics, but it's a good illustration. If you take a sharp knife and you push straight down on a tomato, it will chop that tomato, but it will also squish the tomato, right? But if you take that same sharp knife and you drag it very fast across the tomato, the knife will fall through without any deformation at all. And that's kind of what we're talking about in iMachining when we talk about the cutting edge velocity. There's a ratio, there's a balance in all of this and how this works. And this is what we want to start doing certification classes on for everybody so that we can really get everybody tuned in and using this at its highest level. When the rotational velocity is in balance with the forward velocity of the tool, then the system works. The pressure vector, that red line right there, is pushing directly against the tip of that tool. Now, carbide is a very, very delicate material. I know that's a hard thing to understand and realize, but it's very hard. It's very strong on compressive force, but it's very weak on tensile force. So if we bend it at all, then we're going to break that tool. But iMachining does something very special that ensures that that flute edge is only ever seeing compressive force. It's never seeing tensile force. And so our tool life goes up dramatically even when we're pushing the limits of performance. And that's what we want to kind of get everybody thinking about as we start taking this to that next level. Now, this is what we were doing at the show 2 weeks ago at IMTS. This is in our little desktop machine. And Jack, we got volume at all on this? One of the things you'll see in here, now this is 17.4 pH stainless steel. This is a precipitation hardening steel, for those of you that know what it is. For those that don't, if we do this wrong, it will get very, very hard, very, very quick and snap that tool in a heartbeat, okay? But we were able to do this in such a way that even the executives of Kennametal that came over to our booth and visited us, they watched this video and they were standing there in stunned amazement that on a tiny little machine with a 3 horsepower spindle with a 3/16 inch diameter tool in there that we could cut at this rate. And their VP of part production or tool production looked at me kind of disappointed. He said, "Whose tools are you guys using for this?" And I said, well, it's yours. It's the Kennametal Harvey TI series. He seriously looked me straight in the face and said, no, that's not possible. Our tool can't cut like that. Okay? That was a stunning recognition. When I showed him, yes, it is. It's your tool. Your tool can cut like that. And it'll do that all day long. Okay? Everybody worries that when we're cutting at this performance level, we're damaging the tool, but we're not. We're actually improving the performance of that tool because we're creating only rotary torsional force against it. And so this becomes a very, very interesting dynamic. And this next slide is going to show you exactly what I'm talking about. That pile of chips, we had to clean this thing out. What was it, Kevin? 4 times we had to clean it out? We had to clean the box out 4 times. That tool that's in the spindle and the one before it produced all of those chips. And the cool part is that tool's not done. That tool's got a lot of life left on it, okay? It's still in the machine, shipped back to the office. We can do amazing things with iMachining, and this is all above and beyond the default settings, and we want to teach everybody how to do that. So we're going to start putting together some classes, some online classes, and some certification stuff in the certification portal to be able to get everybody up to this speed. Now, I also want to talk a little bit about something that came up in the managers meeting yesterday. Is iMachining only good for solid carbide tools, or can we use it with high feed mills? Now, this is a 3-flute, 1.5-inch diameter high feed mill that's cutting in Duracast cast iron. This was, before we did this, it was so loud you couldn't stand to be near it, but listen to my voice in this recording.
We're looking at a very low spindle load meter. We're about 37%. This is a 1.5-inch diameter high feed mill.
My voice is actually louder than the cut, standing at the door. Now watch this.
At 60,000 depth of cut.
We can make that tool really move, okay? We can take more material out with these tools using an iMachining style cut than we can using a high feed cut where we're engaging that tool at 80 degrees of engagement. This is a 55-degree engagement, okay? We can tear some material up, and by the way, those inserts, doing it the normal way that the tooling manufacturer recommended they do, lasted 1 pocket and they had to turn the corner. We cut this entire pocket on these inserts and they weren't even discolored yet. The coating wasn't even abraded off of the edge of the tool. So there's a lot we can do with iMachining, even with these style of tools, that might not be something that people are thinking they can do. So we want to teach that. The next thing I want to talk about is exotic materials. We just did some stuff up in our Newtown, PA office, and I think Tim's out here somewhere. Tim did a great job with this. We were cutting in titanium. This is not that video. This is just a video that I happen to have on my machine. But we did some stuff that actually stunned, again, the Kennametal guy that was there with the tool. He couldn't believe that we could cut titanium at 500 surface feet, and we did it. This video is at 950 surface feet. This is on a 3-flute end mill, a 1/2-inch end mill that's 1 inch deep in titanium. Now there's a lot of coolant going on because of course you don't want to cut titanium dry, we don't need fires. But as you can see, a lot of that corner is gone already. Go ahead and bring that volume down just a little bit if you would. I want you to listen to the sound. Notice how that sound is so consistent. The cutting angle is changing continuously as this is going through this cut. But we're cutting titanium at 950 surface feet on a 3-flute end mill faster than anybody I've ever talked to has seen or believed that titanium could be cut at that rate, okay? So that's kind of a unique way of looking at it. Point being, out of all of this, again, if your customers are not using iMachining for bulk material removal, then they're losing money, okay? We can teach how to do that, and we need to do a better job of that. We need to get in and get involved with this and get everybody up to speed on how this stuff works. But we can teach you how to get the most out of your iMachining. And we want everybody to join this revolution. Let's start again and take it to that next level and make sure that what we're doing is ensuring our customers' success, okay?